going to discuss the proper way of organizing a C++ code that uses NVIDIA GPU CUDA. So the CUDA is not just a library or a header files, it's actually extending the C++ language in such a way that it no longer compiles using any the standard C++ compiler. So it added something into the C++ language that is no longer the standard C or C++, so it does not compile. So in order to compile that, so since Coda extended the language, it has actually its own compiler, okay? Because it's no longer standard C++. So let's go directly into the meat and let's go to the project here. And if we examine the makefile, so the, the file name that contains the extended syntax has to have the CU extension or coda. Okay, if you make this CPP or C, then it won't compile. Notice that the compiler used to compile this file is the NVCC. It's not GCC. It is the Coda compiler, the NVIDIA Coda compiler or NVCC. And that's why it needs the CU extension. And again, the topic of this discussion is code organization. Okay, in the example of the NVIDIA Coda, the examples there are written in such a way that the extended language C++ is sprinkled and mixed in the pure C++, and that is not good. Okay, you have to segregate and modularize those functions that extended the C++ into its own file. It is like what I'm doing here. So the functions that contains extended syntax of C++, I put them into this helper.cu file and I compile it into using the Coda compiler and generating a temporary object file .o, and I link this object file into the main app.cpp. I link it, and then this is how I'm able to create the main application. And the result of this way of organizing code is that the main application, if you look at now, is now a pure C++. This is very important, guys, that the the main app should not contain any extended C or C++ syntax. So it should look like standard C, C++, such as what we are looking here. This is standard C, C++. There's no weird symbols here. The reason for this is it will make your application more portable. It will compile to environments that does not have Coda, because Coda is just uh, a speed up technique. It's just increasing the execution speed of your program by parallelizing those parts that can be that are parallelizable. So you cannot just take in an existing C++ code and compile it with code and voila, it's now parallelizable. It is now executing very fast. It doesn't work like that. Such a goal of making an existing C++ code run in CUDA, it requires surgical incision. Okay, it is it needs surgical incision because you need to have to recognize parts of your code that are embarrassingly parallelizable, meaning that they can be parallelized. You have to identify that, and once you do that, you have to create kernel functions, CUDA kernel functions, where this parallelizable block of your code is located. Because, for example, this application is a matrix transpose. and it accesses every element of the matrix which is independent of each cell of the matrix. So the first cell does not depend on the second cell and so on. So every cell is independent. So if the matrix has 1 million cells, then each of those moving of the cells can be done in parallel 1 million times, and it will be very fast. So now you will also notice that there are two compilers here. So the extended language, the extended C++ language is compiled using the NVIDIA compiler, and the standard C++ is compiled using G++. So by segregating this, by doing the segregation, your code is more portable. So I learned this when I examined the image recognition library DLib, DILB by Davis King. It is a huge C++ codebase for face recognition, but 99.9% of that is in C++, whereas only the CUDA parts are just can be found in 3 files or very few files. So the dlib design wraps it such that its main code base is pure C++, and that is how dlib is portable and can be compiled in systems that does not have coda. Of course, as a result, it runs more slowly, but still, your app will compile if you do this code um, proper code organization. I'm stating this because the examples in the NVIDIA Coda are mixing the extended language with the standard language. Of course, for for clarity of the point, okay? But in any project that you do, you have to organize your code so as the extended C++ is in its own separate file, and the pure C++ is in a separate file, and you kind of separate these two. Okay, and let's compile this. So if I type make, so the Coda compiler is generating the the dot o, and then the dot o is linked to the C++ code producing the main application. So if you run the app, so it's now able to transpose the matrix. And let me explain something here. If we go back to the this compilation snippet here, pipe3, this is actually pipe.3. This is the what you call as the compute capability. So it's a version. Since I'm use my GPU here has a compute capability of 5.3, I should specify the compute cap that same version when compiling the code and when producing the .o file. Otherwise, if there's a mismatch, so if my GPU is not so if this compilations instruction is not setting the proper matching compute capability, then your program will not run. For example, if we modify the make file, so if we change this to like 72, and if we build, and then if we run the app, notice that the matrix is not correctly transposed. See, this is the correct output, and this is the output when the compute capability does not match the what is actually present in the GPU. So let's put it back, pipe 3. If you compile it again, and now the matrix is correctly transposed. Now let me switch to another project here, and I'm going to talk about the compute capability, which is this smcop.cpp. So this small program here is meant to programmatically identify what is the compute capability of the system. So if we build this program using this makefile, so I'm using only the standard C++ compiler as the source code. Yes, it is linking to Coda, but it does not contain any extended weird syntax. So we can compile this using G++. And if we run the capability, you can see that I have a coded device, the Tegra X1, and the compute capability is 5.3. So I am programmatically querying it here, and that is how I know. But this is well documented in the web page of the Jetson Nano that for Jetson Nano, which is what I'm using here, is compute capabilities 5.3. This is hardware specific, so it's well known. Nevertheless, I retrieve the value programmatically, and that is how why we need to specify 5.3 here when invoking the NVIDIA compiler. This will tell the compiler to generate 5.3 machine code into the object file. So if we look at the this file here, it has an extension of CU and it has to be CU, otherwise it will not compile. Okay, this is actually the part that contains the extended C++, and the part that is that that the way that NVIDIA is extending the language is the use of these opening bracket and closing bracket. Okay, these will not compile in standard C or C++. So this is Coda extended the language of C and C++ and added this stuff here, this magic voodoo here, such that it is no longer your ordinary in C, C++. So this is exactly the reason that you need to separate those portions of the code that contains these extended syntax. Okay, this here. Furthermore, you can see this global keywords or decorator in the transpose function, which actually tells that the body of this function is parallelizable, meaning that this transpose function can be simultaneously executed a million times at the same time together. And for each instance of the call, it has a coordinate xy and is accessing different parts of the array of the float. So that is how parallelization is achieved through this expression here. And yeah, you can see that we can achieve this through C++ template, right? Because C++ is the Dragon language. You can extend it to any shape, and it can become any language through operator overloading. Yes, you can do that in C++, but can you do that in C? No, you cannot. And since C is the standard glue of different languages, the universal atom of how languages are glued together, and that is why Coda is compelled to extend the language because of C. So this is for the C, because usually the Coda is run in C. And so the result of this code organization is that the main application is now pure C++, and then your Coda, those parts that contain the extended syntax of C++ is separated in its own file here, and this makes your application more portable and it's better organized this way. In the example code, they are mixed because for clarity of in a real project you have to separate those parts that contain the extended C++ syntax.